Let's solve problem 1, where we have been asked to find the value of this expression. So we can solve this problem by applying the distributive property. So we start with the given expression. And then we can write it like this. Now I will write it. And then I will apply the distributive property again. And then I can multiply. Now I will cross out these numbers, and also I can if I solve, I would get 1, and if I solve this number, I would also get plus 1. So the answer is then 2 for this problem. So the answer is A. Now let's look at problem 2, where we have a model that is used to estimate the time it will take to hike to the top of the mountain, and it is given in this form. And we are also given that the model, it estimates that it will take 69 minutes to hike to the top if a trail is 1.5 miles long and ascends 800 feet, as well as if a trail is 1.2 miles long and ascends 1100 feet. And we have to estimate how long it will take if trail is 4.2 miles long and ascends 4000 feet. So let's start with the model or the linear equation that is given. So we have time equal to AL plus BG, and we will start solving for A and B. First we need to find the constant or the parameters for this equation, and then we can find out for the given case. So if you see, we are given this information that the model, it estimates 69 minutes to hike to the top if 1.5 miles long and ascends 800 feet, and if it is 1.2 miles long and ascends 800 feet. So we can set up our two equations. So I would have then 69 is equal to A 1.5 plus B 800. So this is equation 1. Similarly, I can write the second equation, that is A would be multiplied with 1.2 plus B 1100, and this is equation 2. So now if you see, we have now two equations and we also have two unknowns. So we can solve them either by the elimination method or substitution method. But in this specific case, if we apply the elimination method or substitution method, the problem can get a bit long. And so in order to solve the time, it would be easier if you just subtract equation 2 from equation 1. Okay. So then on the left hand side, I would have 0 because these two numbers they will cancel out, and I would be left with 0.3a and minus 300b, right? And now I can rearrange to find the value of a in terms of b. So for that, I would get a equal to 300b over 0.3. So now I can write it like this: a is equal to 1000 b. And now what I have to do, I can plug this expression or this relation between a and b in equation 1. So if I do, then I would get 69 is equal to 1.5 to 1000 b plus 800 b. And then it is now 1500 b plus 800 b, and upon further solving I get 2300 b equal to 69, and so if you solve it, you would then get 3 over 100, right? Or you get 0.00 sorry, 0.03. Okay, so this is the value of b is. So to get a, just simply plug that back, and then a is equal to 3 over 100 multiplied by 1000. So then a is 30. Okay, so now we will put these parameters a and b in the general equation to find the time for the given case. So the linear equation that we have is and after plugging the values, we have 4.2, and we have 4000 feet the height. So if we solve it, then we would get 126 here, 120, and the answer is then 246 for this problem. So the answer is B. So let's look at problem 3, where we have to find the sum of the digits of the smallest prime that can be written as a sum of 5 distinct primes. So let's start with the first 5 primes and see what is the sum. So we have 2, 3, 5, 7, and 11. So if I add them, I get 18 and then 23, 26, and 28. But the number that I get, that is a even number. So it means that I have to take 2 out. I cannot consider 2 because otherwise it is not giving me a next odd number or a prime number. But I need a prime number. So in that means that I need an odd number as well. So next, let's try 13. So if I add now, I would get 24, 31, and if I add, I get then 39. So if I add them, as I say, like the answer is 39, but still 39 is not a prime. So then I would change 39. Sorry, I would change 13. So I cannot use 15. It's not a prime. So I would then try 17. So if I add now these numbers, I get then 28 and 7, 35, 40, and 43. So 43 is a prime. So if I add its digits, I get then 7. So the answer is then B for this problem. Okay, so now let's look at problem 4, where we are given that the number 2024 is written as the sum of not necessarily distinct two-digit numbers. What is the least number of two-digit numbers needed to write this sum? So for this problem, we need to be careful for two things. First is that the numbers, they cannot be distinct. And the second, that we have to tell the least number of two-digit numbers. So for such problems, we will maximize two-digit numbers. And then we'll see what is the remaining number that we need to in order to get the sum, for example, for 2024. So in other words, for 2024, we can write it as 20 times 99. So I'm basically maximizing the number of 99s here. And then I will simply add the remaining number that we need to get the sum equal to 2024, and that number is 44, and we need 1 times. So now the total number of two-digit numbers that we need, they are 20 plus 1. So the answer is then B for this problem. Now let's look at problem 5, where we have to find the least value of n such that n factorial is a multiple of 2024. So for such problems, first we will get the factorization of the given number. So I will see what are the prime factors for 2024. Now with 11, I can get to 23, and then I get 1. So the prime factors that I get for 2024, they are 2, 11, and 23. So now for n factorial to be divisible by 2024, it is required to have at least all of these prime factors with the same power as they are appearing in 2024. So therefore we need 23 appearing at least once, 11 and 2 should be appearing at least 3 times. So as we know, like 23 is a prime number. It can only appear if we have 23 factorial. So if I expand it, I would get then 23 multiplied by 22 multiplied by 21 and so on. So therefore the least value of n that we have, that we need, that is 23. So D is the answer for this problem. So now let's look at problem 6, where we are given that what is the minimum number of successive swaps or adjacent letters in the string A, B, C, D, E, F that are needed to change the string to F, E, D, C, B, A. So we are given this string A, B, C, D, E, F, and we have to change it to this form F, E, D, C, B, A. So we will swap one letter each time. So if we swap A first, so if we swap A to F, so we need to make total 5 swaps, right? And then the string we will get is B, C, D, E, F, A, and it will be after 5 swaps because we make one swap, 2, and similarly 5. So now we have this string, so we will now swap B to F. So for that we need to make now 4 swaps, right? So because we will make 1, 2, 3, and 4. So that would give us then C, D, E, F, B, A after 4 swaps. So similarly, if we continue, then the next time our number of swaps will reduce by 1, and we will have 3 swaps, then we have 2 swaps, and then we have 1 swap. So if we add this up, then the answer that we will get is 15. So D is the answer for this problem. Let's look at problem 7, where we are given that the product of 3 integers is 60. What is the least possible positive sum of the 3 integers? So let's assume that the 3 integers are x, y, z, and we know that the product is 60. So we have to find what is the least possible positive sum. So to ensure that the number that we are given, or the product is positive, we can have 2 numbers maximum as negative. We cannot have all 3 negatives because otherwise then the product will not be positive. So now we can start with combinations. Let's say that we start with 30. If we have 30 dot negative 2 dot negative 1, it gives us 60. So if I write the sum of these 3 numbers, the sum is 27. But now we need to see, like, can we have lower than this? So definitely we can have, but for that we need to use positive number, the smallest possible. So let's see what smallest possible we can have. So we can start with 10. For 10 we can have -3 dot -2. That is also equal to 60, and the sum is now 5. So now we can see like what other options we have. So we can have 10 -6 -1, that is 60, and the sum is now 3. So from here we can see like any other combination that we use, so that will give us a larger number. So then the smallest possible value that we can have is 3, and the answer is then B for this problem. Okay, so now let's look at problem 8, where we have that Amy, Bomani, Charlie, and Daria work in a chocolate factory. On Monday, Amy, Bumani, and Charlia started working at 1 p.m. and were able to pack 4, 3, and 3 packages, respectively, every 3 minutes. At some later time, Daria joined the group, and Daria was able to pack 5 packages every 4 minutes. Together, they finished packing 450 packages at exactly 2:45 p.m. At what time did Daria join the group? So there are 4 people who are working. We can label them as Amy, Bomani, Charlie, and Daria. And the first 3 they are packing at the rate of 3 minutes. So every 3 minutes. So they're having 4 over 3, 3 over 3, and 3 over 3. So basically 4 packages every 3 minutes. And Daria, he did packing at 5 packages every 4 minutes. So he did 5 packages every 4 minutes. So what we know that Amy, Pomani, and Charlie, they started at 1 p.m. and they finished at 2:45 p.m. So the total time that was taken by, I would write it like A, B, and C, is basically 2:45 p.m. minus 1 p.m. So that is actually 1 hour and 45 minutes, or equal to 105 minutes. So during this 105 minutes, the packing that they did, or the number of packages that they packed, we can find that. So like I said, then total packed by A, B, and C, that is equal to 105 divided by 3 and multiply by 4 plus 3 plus 3, and that would be then equal to 350. So they did packing for the 350 packages. So then packing by Daria, or the number of packages that Daria packed, that is equal to 450 minus 350, and that is equal to 100. And now we need to see that how long it take by Daria to do this complete packing. So I will say time taken by Daria. So that is equal to 100 multiplied by the rate. So she has, it would be then inverse. So it would be 4 over 5. So if I solve, I get 80 minutes. So now Daria took 80 minutes. So it means that she joined then 245 minus 80, and that would be then 125, right? Yeah, so it would be then 125. So then the answer is A for this problem. Okay, so let's look at problem 9, where we have in how many ways can 6 juniors and 6 seniors form 3 disjoint teams of 4 people, so that each team has 2 juniors and 2 seniors. So as given in the problem that we need to form 3 teams. So for the team 1, we have 6 seniors available and we are choosing 2 people from them. And similarly, we have for juniors, we have 6 juniors available, and then we are selecting 2 from them. So if we solve this, then for team 1, the number of ways that are possible are 225. So now let's look at for team 2. So for team 2 now we are left with 4 seniors and we are choosing 2 from them. And similarly we are left with 4 juniors and we are choosing 2. So now if I solve, I will get then 36. And for team 3, now only one option is left since there are only 2 juniors and 2 seniors left. So there is only one way. And the total ways is equal to 225.36.1, and we will divide it by 3 factorial because the order, it doesn't matter in this case. So then if we solve, the answer that we get is 1350. So the answer is B for this problem. Okay, so now let's look at problem 10, where we have that consider the following operation. Given a positive integer n, if n is a multiple of 3, then you replace n by 3. If n is not a multiple of 3, then you replace n by n plus 10. Then continue this process. So we have then asked that you start with n equal to 100 and what value results if you perform this operation exactly 100 times. So for such problems, we don't need to perform operation 100 times because it is very time consuming. So what we do, we basically find a pattern and then based on that we will find out the value. So the number that we start with is 100, and since it is not a multiple of 3, so I will then add 10 and add 10 again, and now I divide it by 3, add 10 again, add 10 again, now divide by 20, and then add again and it becomes 30. Now add 10 again, it becomes 40. Then if I add, sorry, here I should have divided by 3, so it becomes 10. And now if I add 10, it becomes 20, and it becomes 30, and then 10. So now if I see here, a pattern has started emerging. So if you see, we get 20, 30, 10, 20, 30, 10, right? So now if you see, after applying operations 1, 2, 3, 4, 5, 6, and 7 times, the pattern, it started emerging, right? So we had 30, and then if I apply this operation 3 times, now I'm getting 30 again. So the total number of times that we want to, or we are asked to apply the operation is 100. So 100 minus 7, I get 93, right? So after applying the 7 times in this operation, I get 30. So now after getting 30, if I apply this operation 3 times again, I get 30 again. And then this cycle, it continues. So, and the total operations that are left to apply after this 30 is 93. So if I divide 93 by 3, I get 31. So this loop, it will continue 31 times, and then it will end with the value of 30. So the answer for this question is 30. That is C. Let's solve problem 11, where we have to find out the number of ordered pairs of integers mn that satisfy this relation. So for this problem, first I will rearrange the given equation. So the equation is here, and I will apply or take the square on both sides of this equation. So then I will be left with uh, n square minus 49 equal to n square. Now if I rearrange it, I would get then m square minus n square equal to minus 49, or I can write it like this. And now if we see that this is difference of squares, right? We can set it up like that. So I can write it n minus m and n plus m equal to 49. So from here now we can see like what ordered pairs will satisfy this equation, and those basically are the ordered pairs that are possible for m and n. However, from here we can make one observation that n plus m is greater than or equal to n minus m. So we need to keep this in mind. So based on this, we can see like what pairs are possible. So definitely we can have the first one could be then minus 49 minus 1. So it would satisfy this equation. So the second pair that is possible is minus 7 minus 7. That is also possible. The next possibility is 149, and then we can have 7 and 7. So the total pairs that are possible are then 4. So we do not need to explicitly find the values of m and n in this problem. Uh, but if you wish, you could do so based on the time that we have. It is better just to solve the problem to identify the ordered pairs that can satisfy this expression. That's all that you have to do. So the 4 is the answer for this problem. Let's look at problem 12, where we are given that Zelda played the Adventures of Math game on August 1st and scored 1700 points. She continued to play daily over the next 5 days. The bar chart below shows the daily change in her score compared to the day before. So what was Zelda's average score in points over the 6 days? So we have to find the average score that she has scored. So we are given this chart that shows the change in score uh, like with respect to the previous day. So like if you see for day 1, she scored, let's say, 1700. Then day 2 is 1780, right? Because the score was higher. And then it was negative 90. So the day 3 score is 1690. Then day 4 score, if we calculate, that would be 1680. And then day 5 score is now we are adding 60, so it is becoming then 1740. And then we have day 6, so that score is dropping 40 again, so it's going back to 1700, right? And now we have to take the average, so we basically simply sum these days up and see what is the average. So that is 1700 plus 1780, 1690, 1680, 1740, and then plus 1700, right? So this whole thing, if we divide it by 6, so then we will get our answer, and if you solve it, then the answer that you get is 1715. So E is the answer for this problem. Let's look at problem 13, where we are given that two transformations are said to commute if applying the first followed by the second gives the same result as applying the second followed by the first. And we have to consider these 4 transformations. The first one is the translation, then a rotation, reflection, and a dilation. And we have to tell of the 6 pairs of distinct transformations from this list how many commute. So for this problem, let's say that our coordinate plane is xy. And now let's write the mapping for each of this transformation. So for the first one, xy, we get x plus 2y. The second one, then we can say is xy to minus yx. The third one is then xy to x minus y. The last one is xy to 2x, 2y. Also, let's name each of these transformations. The first one I would name as T1, T2, T3, and T4. So now we need to see which transformation they commute, right? So for that, what we have to do is simply, let's say first we check for T1 to T2, and then we will also check from T2 to T1. So basically what we're checking that if we apply first T1, then apply T2, or if I apply T2 first and then apply T1, is the answer same or not? So if I apply T1 first, so that would give me the x plus 2 y, right? And now if I apply T2 on this, then I would get minus y x plus 2. Okay, so now let's see if I apply T2 first and apply T1, what do I get? If I apply the T2 first, so I'm still starting with xy, and since I'm applying T2 first, then I would get minus yx, and then I get here minus y plus 2 and x, right? So if I see now both of these mappings or the results, they are not same, right? So therefore I would write it that do not commute. So this was the first pair, right? So similarly I have now five more pairs, so total pairs I have is 6. So now let's check one more pair, and then the rest you guys can solve it in the same way. So let's see the next pair that we are going to check is T1 to T3, and then we will check T2 to T3 to T1. So if I'm starting again with T1, now I have again xy. So I would get then x plus 2y, right? And then I'm applying T3. So then I get x plus 2 minus 5, right? 2 minus 5. And now if I apply T3 first, then I get x minus y. And now if I apply T1, I get the translation along x-axis, and I get minus y. So in this case, if we see now the result is same, right? So we can say that it commute. So in the same way, we will check for the next like the pairs. So I will just write now the pairs, and then I will let you guys do it yourself. So you will check T1 first, T4 second, and then T4 first and T1 second. And then we will check T2 to T3, and then we'll check T3 to T2. And then you'll also check T2 to T4 and T4 to T2. And how many pairs we have? We have 5 pairs, so then the remaining pair is now we will check T3 to T4 and also T4 to T3. So these are all the pairs that you have to check. So if you check all the pairs, then you will find out that the uh, the pairs that commute, they are actually 3. So the answer will be C. But I'm leaving it to you to solve. If you have any question, then write it in the comment section and then I can explain there. Okay, so now let's look at problem 14, where we are given an equilateral triangle of a height 24 and it lies on line L. And then we are given a circle of radius 12 that is tangent to line L and is externally tangent to the triangle. The area of the region exterior to the triangle and the circle and bounded by the triangle, the circle and line L can be written in this form. So these are the positive integers, and b is not divisible by the square of any prime. So what is a plus b plus c? So in this problem, I have already drawn this diagram, as can be seen. Basically, what we have to do, we have to find the values of a, b, and c. And as it has been given already that the area of the region exterior to the triangle and circle bounded by this is represented with this expression. So basically, it means that this expression, it represents the area that is bounded by this region, bounded by these lines. Okay. So let's first label this triangle and also the circle. Then it would be easier to work with. So let's say I call it A, B, C. This is then, let's go D, E. This is the origin. I'm just gonna call it O. And this is 12. And the height that I get from here to here, that is given as 24. So to find the area of the sector, what I can do, I can simply create a trapezoid. Okay. So the trapezoid I'm going to represent with the black lines. Okay. So now if from this figure we see that the area that we are interested in, that is simply equal to the area of the trapezoid minus the area of the sector, right? I'm talking about this sector, this sector. Okay. Since the triangle that I'm given, it is an equilateral triangle, so all angles are 60 degrees. If this angle is 60 degrees, so then the angle that is inside, that would be 120 degrees, right? And if this angle is 120 degrees, let me write it clearly. So this is 120 degree angle. So then, as we know that this angle for the trapezoid and this angle, they are both 90 degrees. So this angle then is 60 degrees. Okay. So from here we can see that to find the area of the trapezoid, we basically need to know the two sides. So two of that we know already, right? So let's say this is 12, we know this is 12, right? But we don't know the other two sides. However, what we can do, we can divide this trapezoid into two triangles, right? So now if I divide this trapezoid Okay, then I can get a triangle that is a 90, 30, and 60 triangle. Okay, then let's call this triangle X, Y, Z. So we know this is 12, and as we know, for 30, 60, and 90 degree, we can easily get the other two dimensions if we know the one. So this dimension, it would be then 4 square root 3, and this is 8 square root 3, right? And simply twice the area of this triangle. That means I have 2 times 1 over 2 times 12 times 4 square root of 3, right? And the sector is simply 1 over 6 pi r square, right? And the reason is the sector that we have, that is making a 60-degree angle. So 60 divided by 30, 360, I get 1 over 6. And now if I solve, I get, then this cancels out, I get 48 over 3 minus 1 over 6 pi, and 12 times 12. And if we simplify, I get 2. And then I get 48, this minus 24 pi. So from here now I can simply read a plus b plus c. So a plus b plus c, that is equal to now 48 plus 3 plus 24, and then the answer is 75 that I get. So this is how we can simply solve this problem. Okay, so now let's look at problem 15, where we have that let m be the greatest integer such that both m plus this number and m plus this are perfect squares. What is the unit digit of m? So let's first express both squares as p square and q square. So p square is equal to m plus 1213, and q square is equal to m plus 3773. And if I subtract equation 1 from equation 2, I can write as q square minus p square equal to 2560. M's will cancel out, right? And also now the left hand side, it can be represented as q minus p, q plus p equal to 2560, right? If we make one observation that we want m the greatest integer, right? So for that, we need to ensure that q and p are also maximized or the largest possible. And from there, we can also make one observation that we want then q plus p to be the maximum and q minus p to be the largest. So if I write the factorization for 2560, that give me the maximum value for q plus p, then one option is definitely this, right? So I can have q minus p equal to 1 and q plus p equal to 2560. However, if I calculate the values for q and p based on this, I would see that they are not integers. So I have this, and then I plug this number and I solve, I get 2q equal to 2561, right? So that means that q is not integer anymore since it is divided by this, right? So then I will exclude this option and I will check the next option. In the next option, I can have 2 dot 1280, right? So that is also, as we know, equal to 2560. And from here now, I can calculate the values for p and q. And if I solve, then I would get, so if you solve these equations, then q is equal to 641, and p is equal to then 639, right? Okay, and both of these are now integers. And now what we have to tell that what is the units digit of n, right? So what we can do, we can now write the equation in this way that m is equal to p square minus 1213, right? So now if I plug p square, that is given 639 square minus 1213. So now I don't need to solve this full square. All I know that the unit digit for 9 it's going to be 1, right? And there will be something before this. And minus 1213 I have. So then the unit digit that I will get, that will be 8, right? So I can also check now for the other case as well, where I have q square minus 1213, and here I have now 641 square, right? Minus 1213. So again, if I see the unit digit that I would get from here is 1 minus 3, so that would be again 8. So the answer for this problem is then E. Okay, now let's look at problem 16, where we are given that all of the rectangles in the figure below, which is drawn to scale, are similar to the enclosing rectangle. Each number represents the area of the rectangle. What is length AB? So it is important to understand that the larger rectangle, it is similar to the smaller rectangles. So that will allow us to write the ratios of the corresponding side lengths equal to the square root of the areas. So first we will calculate or get the total area for this larger rectangle by summing up these areas. So if we solve, then we get area equal to 200 unit squares. And now let's label this rectangle, and we're taking height as x, and height, it represents the smaller dimension, and we are representing y as the width, and width is representing the larger dimension of the larger rectangle. And now we will try to express the uh, the length of the smaller rectangle in terms of x and y. So I will start with the left hand side, and let's say that this side it is p and this side it is q. So now I can write it that p over x is equal to square root of 32 over 200, and that is equal to then 2 over 5, or p is equal to then 2 over 5 x. And similarly, I can also write expression for the next rectangle, and I can write it now q over y equal to 36 over 200. So I'm taking y here because we are uh, taking the larger length now. Okay, so q is the larger length and y is also representing the larger length. So that's why we are writing q over y equal to 36 over 200. And if we solve this, then we get 3 square root of 2 over 10. Or we can say that q is equal to 3 square root 2 over 10 y. So now what I would do, I can write the total height of the larger rectangle as x equal to p plus q, or that is equal to 2 over 5x plus 3 over 10 square root, sorry, in this y. Okay, so if we solve this and we find the value of x, then we will get y over under root of square root of 2. Okay, I'm just skipping this step of solving this because it's just simply algebra, and I'm pretty sure you guys can do yourself. So now what we have to do, we have to now find y, right? Or the value of y. So we know that the area is xy, right? And also we know x is y over square root 2 y, and area is 200. Okay. So now I can write it y square equal to 200 square root 2, or I can also write it like this, or we can write it as, so now if I take square root on both sides, I would get y equal to multiply by 100, and so sorry, it would be now 10. So now let's look at problem 17, where we are given that two teams are in a best 2 out of 3 playoff. The teams will play at most 3 games, and the winner of the playoff is the first team to win 2 games. The first game is played on Team A's home field, and the remaining games are played on Team B's home field. Team A has 2 by 3 chance of winning at home, and its probability of winning when playing away from home is P. Outcomes of the game are independent. The probability that Team A wins the playoff is 1 by 2. So we are given the total probability as well, and we have to find what is n plus n from this expression. Okay, so we see the probability of Team A when plays at home is 2 over 3. So in this case, the probability of the team B when they're playing at A would be 1 minus 2 over 3, okay, or it would be 1 over 3. And when team A is playing away, then the probability that we are given is P, and the probability for team B in that case, it would be 1 minus P, right? So now if we see, like, there are 3 possibilities that we have, right, based on the description that we are given. So one of the probability is that team A wins first 2 games, right? So in this case, if we see the probability, then we will have that would be 2 by 3 P, right? The second case that we have is team A wins the first game, then team B wins, and then team A wins the third game. So in this case, the probability that we will get, that is 2 by 3. For B, we will have 1 minus P and P, right? Now let's say we have, what's the third possibility? The third possibility is team B wins the first game, and then team A wins the next 2 games. And now the probabilities that we have is 1 over 3 for team B, and for A's we will have the probabilities that are P dot P, right? Okay. So now we are also given the total probability, right? Team A wins playoff is 1 over 2, right? So then we can write that 2 over 3P plus 2 over 3 into P minus P square plus 1 over 3P square is equal to 1 over 2. So now we can simplify this equation, and if I multiply both sides by I would multiply by 6. Okay, so then I would get 3 here, and I get on this side 4p. Here I would get then again 4p minus 4p square, right? And plus I would get then 2p square. And now if I simplify, I would get minus 2p square plus 8p minus 3 equal to 0. Or I can also write it like this, right? And now I can apply the quadratic formula to find b. So that would be then equal to minus b plus minus b square minus 4ac over 2a. And then we get 8 plus minus 64 and minus over 4. I would get 40 over 4. That is equal to now 8 plus minus 2 10 over 4. Or I can further simplify and I would get plus minus 10 over 2, right? And from here I can see or I can relate it with a given expression. For the given expression we were given the negative sign here, right? So if we discard the positive one, just keep the negative one, and then we can keep the values. So the values that we get for m plus n, so they are then 4 plus 10, that is 14. So the answer is then. So now let's look at problem 18, where we are given that there are exactly k positive integers b with this range such that the base b integer is divisible by 16. What is the sum of the digits of k? So we have to find out the positive integers b, which are in number equal to k, and then we have to sum up the digits of k. So if we see the number that we are given, it is given in base b. So we can write this number like this. We have 2024b, that is equal to 2 multiplied by b to the power 3 plus 0 multiplied by b to the power 2 plus 2 multiplied by b to the 1 and plus 4 multiplied by b to the power 0. And if you see, we are already told that this number, it is divisible by 16, or I can write it that equal to 16x. So since this number, it is divisible by 16, and if you see that this number, it has 2 in common, right? So then I can also express this number as plus b1 plus 2, and that is equal to now 18x. So basically the number that we have, it should be divisible by 8. So now what we need to do, we need to find out for which numbers this number or this expression, it is divisible by 8. So what we can do, we can start with 0 and go all the way up to 7 with 0 first. So if b is 0, then if we solve, we get, so then the remainder is 2. So that is not divisible by 8. Okay, so we will not count it. Next, let's check with 1. So now I get 4. That is still not divisible by 8. 12. So that is still not divisible by 8. Now I get 32. And 32 is divisible by 8. Now I will check 4. 70. So that is also not divisible by 8. I will check 5. So that is now equal to 32. So this is not divisible by 8. Now let's check 6. So if I solve for 6, then I get 216 plus 6 and 224. That is divisible by 8. So now let's check 7. So then I would get 352. So that is also divisible by 8. Okay, so now if we see based on our work that out of these 8 numbers, 2024 is divisible by 3, right? So what we can do now, we can find out all the numbers by simply dividing 3 by 8 and multiply by 2024. And that would give us then 253, and if we multiply then we get 759. However, we should keep in mind one thing, that the range that we are given is b is greater than or equal to 5 and less than 2024. So then we have to subtract one number. That was this case 3, since it doesn't come in this range. So if I subtract, then I get 758. And now I will add these 3 digits to get all the k integers. So that is equal to then 20. So that is the answer for this problem. Let's look at problem 19, where we are given that the first 3 terms of a geometric sequence are the integers a, 720 and b, where 720 is greater than a and less than b. What is the sum of the digits of the least possible value of b? So we are already told that this is a geometric sequence. So based on that, we can write the ratio of 720 to a equal to b over 720 because of the common ratios. The common ratios are same in the geometric sequences. So now if I rewrite this expression, I can write it like this: b is equal to 720 multiplied by 720 over a. And now I have to answer that what is the least possible value of b. So if we look at this sequence, b is appearing after 720, so it should be greater than 720, right? So in order to get the largest possible value for b, a should be small, right? But it should be smaller than 720, and so the b can be the least, right? So a should be less than 720, but the largest possible value for some, like less than 720. So now what we can do, we can get the factors for 720, and if I quickly do that, I would then get so these are the factors that I get for 720. Then I would write it as 2 to the power 4 multiplied by 3 to the power 2, 5 to 1. And now I would write the same for this as well. Over a. So if I put these powers together, I can write it like, so once I have written it in this form, now all I have to do is to do some experimentation. With the experimentation, I have to find what is the largest possible value for this combination but less than 720. So for that, the condition that needs to be met is that this number or this value, it should be a multiple of a. So if I do some experimentation, then I would get 3 to the 3 multiplied by 5 to 2. That would give me the largest possible value. And if I solve it, then I get 675. And by adding the digits, I get then 18. So the answer is in D for this problem. Now let's look at problem 20, where we are given that let S be a subset of these numbers such that the following two conditions hold. If x and y are distinct elements of S, then the magnitude of x minus y is greater than 2. If x and y are distinct odd elements of S, then x minus y, the magnitude of x minus y is greater than 6. What is the maximum possible number of elements in S or in this subset? So let's first understand these two conditions. As per first condition, if we have two distinct numbers, let's say if I have 1 and 2, then the difference is 1, right? So that is not greater than 2 and it will not satisfy this condition. So in order to satisfy the first condition, let's say if I take 1, 4, it is 3, so it would satisfy this condition, right? So now similarly, let's check for x minus y, where we have distinct odd elements. So let's say that if I take now 1 as odd element and I take 5, it will not satisfy this condition, right? Because the difference is 3. So I will need a greater number or a greater odd number to have a difference of greater than 6. So to solve this problem, what we can do first, we need to actually find a pattern. Otherwise, it is not possible to check each number from this total set. So what we can do, we can start checking from first 10 and see if there is any pattern, or from first 20. And then based on that, we can find out like what are the total numbers that are possible. So I will write down here numbers up to 20. 1, 2, 3, 4, 7, 9, 10, 11, 12, 13, 14, and 20. So now, as we know, based on the first condition, 2 and 3 are not possible, right? So similarly, if I see, I have now 4, and the next digit then I can have, that is, should be 8, right? So this is also cancelled out. And once I have 8, then the next digit that I can have, that should be then 11, right? And now if I check next, I would then get 14. And similarly, if I check the next digits based on the conditions, 18 minus 14, I would get then 4. And if I have 17, yeah, that would not. So then I would get, I would then get 18 as a next digit, and also 19 and 20 will not be possible. So now if I see from the first 10 digits, there are 3 digits which satisfy these two conditions, right? And now if I check the next 10, then again there are 3 digits which are satisfying this condition. So the total number that I am given is 2024. If I divide it with 10, because we are making this observation for every 10 numbers, then I can write it 202 remainder 4. And then from each of these 200, each of 10 numbers, there are 3 numbers which satisfy the condition. So it would be then 202 multiplied by 3 plus, since there is a remainder 4, and from the first 4 numbers, 2 numbers are satisfying the condition. So I can add, and then if I solve, I would then get 608. So that is the answer for this problem, C. I hope it makes sense to you. Problem 21, where we are given that the numbers of each row and numbers of each column of a 5 by 5 array of integers form an arithmetic progression of length 5. The numbers in positions are given, and we have to find a number in position 1, 2. And if we see, we basically have to find this number that is given in position 1, 2. And we are given a very important piece of information that this is an arithmetic progression. And as we know, in the arithmetic progressions or the sequences, the difference is constant, right? So to solve this problem, we can start from this lower right corner. And as we know, we are having a 0 here, right? So I can then call the next term, let's say x. Then I can say this is 2x, 3x, and 4x. The reason is the difference, it is constant, right? So therefore I can write terms like this. And similarly, if I go towards left, I can call it to y, 2y, 3y, and 4y. Now what I have to do, I have to establish the relationship between these terms and some of the numbers which are given for some positions. So then, based on the fact that this is a arithmetic progression, I can write this number as 32 minus 2y. Then the next number I can write as 48 minus 4y. And the next will be then 64 minus 6y. Okay. So once I have written these numbers, what I have to do, I have to now find out like two equations, or I can make two equations so I can find the values of x and y. That will ultimately lead me to find the number for the given position. So I can first of all establish one equation based on this. So I can then write it 48 equal to 48 minus 4y plus 3x over 2. And similarly, I can form another equation that I can write it like based on this, that I can write like 32 minus 2y equal to 12 plus 2x over 2. So now if I solve these two equations like with any of the methods, then I will get x equal to 20 and y equal to 3. I have to skip the part of solving the equation because I'm pretty sure you guys know how to use substitution method or the elimination method, and you can do it yourself. And once we have these numbers or these values, so then we can plug these values back into the matrix that we are given and see what do we get. So since I am interested in this row, that is the first row, so I will only focus on that. So in the first row, the first element is unknown, Second, we want to find. Third one, we know expression, that is this. Then the next element is unknown, and then we have 4x. So if I plug this value, I would get 80 for this one, and if I plug this y, then I would get 46. And now to find what value do we have for this one, we can get it by subtracting 46 from 80 and then adding this term. Okay, so this basically this is our constant difference, right? Or that is 17 if you calculate it. And once I get this value or the constant difference, so then what I can do, I can simply subtract from minus 17, and then I can say that this value is 29, and that is the solution for this problem. So now let's look at problem 22, where we are given that let K be the kite formed by joining two right triangles with legs 1 and square root 3 along a common hypotenuse. 8 copies of K are used to form the polygon shown below. What is the area of triangle ABC? So we are given a kite here, and all the dimensions are given as well. That is here, and this polygon, it is made from 8 kites, right? So let's first identify the kites in this polygon. So if we see here, this is first kite. This is number 1, 2, 3, 4, 5, 6, 7, and 8. So we have these 8 kites here, right? As you can see. Now we have to find the area of this triangle, right? The one that I am highlighting in green. So for that triangle, what we need to know the base. So base, that is AB, and also we need to find the height, right, of this triangle. So once we know the height and base, then we can simply calculate the area of this triangle. So let's first see how we can get the height. First let's go for the base, then we go for the height. So to get the base, we can see that this is an equilateral triangle, right? So then this length that I am turning into red, this length, it is the height of this equilateral triangle. And we know that from this kite that this is square root of 3, this is square root of 3, and then this is equilateral triangle, so this is also square root of 3. So if I write area of a equilateral triangle is equal to 1 over 2 base times height, right? And one side is square root of 3, so then I can calculate the height by also entering the value of base. So now if I simplify, which cross out 2, and then the height that I get is 3 over 2. So this height is actually now representing this dimension. And similarly, since they were the kites that I showed earlier, and they have this length is same for all of them, so this is all 3 over 2. And now if we add these, so we will get 6. So then this dimension from here to here is 6, and for one of the case it is 3 over 2. And now we need to find the height, right? So to find the height, what we can do, we can simply make use of this diagonal, and then we can find this height. Okay, let's call it a h, and this point we have is c. What we know already that from here to here it is 1. This we already calculated. This is 3 over 2. And now we need to know what is the length of this diagonal is, right? This diagonal. So that we can get that from this triangle, the one that I just turned into red. And this is square root of 3, this is square root of 3, this is 1. So if I calculate, then this length AC is equal to simply plus 1 square. And if I calculate, I will get square root of 13. Okay. Now, by using this square root of 13 and this dimension, I can get AH. So AH is equal to now square minus, I have 5 over 2 square. And that is now equal to 13 minus 25 over 4. So that is then 27 over 4. So this is the 27 over 4 square root, right? Or I can then write it as 3 over 4. Then this is the height that I get over 2, not 4. And once I get the height, and I also have the base, right? So then I can calculate the area of ABC. So then the area for ABC is 1 over 2 dot 6 dot over 2. So now if I solve it, then I would get 9 square root 3 over 2. And the answer then for this problem is B. Let's look at problem 23, where we are given that integers a, b, and c satisfy these three equations, and we have to find the value of ab plus bc plus ca. So if you look at the equations, so we have three equations that are ab plus c equal to 100, then bc plus a equal to 87, and ca plus b equal to 60. And in very simple words, we have to answer a question that what is 100 plus 87 plus 60 minus a plus b plus c. So we have to find either the value of a, b, and c, or some sort of combination for them. So let's first add equation 1 and 2 and see if we get some information. So now I will add 1 and 2, and I get AB plus BC plus A plus C equal to 187. And if I factor, then I can write B plus A plus C equal to 187. From here, as we know already that A, B, and C are integers, then the possible values for B plus 1 are plus minus 11 and plus minus 17, right? B that I get, they are minus 12, 10, minus 18, and 16, right? And now let's see what happens if I subtract 2 from 1. Then I would get minus BC and plus C minus A equal to 13. Or I can then write it as, since this is not the same pair, so I would have to write then as a B minus A and A minus C equal to 13. Now the possible values that for B minus 1 that I have, they are plus minus 1 and plus minus 13. And the possible values of B that I would get now, that is a negative 12. So if I see from both of these equations, I'm getting a negative 12 as a common in both. So that means that negative 12 is the answer for B. So now let's see what is the value that is possible for uh, A plus C. So since we know that B is negative 12 and we also know that B plus 1 A plus C is 187. So then if you add minus 20 plus 1, so from here then we can get that A plus C is basically 187 over negative 11. So that is 1, and that is 17. So then the value that we want to find for AB plus BC plus CA, that is simply then 100 plus 87 plus 60 minus, we have minus 17 and minus 12, right? Minus 12. So if we solve, then we will get to 276, and that is the answer for this problem. Okay, so now let's look at problem 24, where we are given that a bee is moving in three-dimensional space. A fair six-sided die with faces labeled these is rolled. Suppose the bee occupies a point ABC. If the die shows A plus, then the bee moves to the point A plus 1 BC, and if the die shows A minus, then the bee moves to the point A minus 1 BC. And similarly for the other options. Suppose the bee starts at point 0, and the die is rolled 4 times. What is the probability that the bee traverses 4 distinct edges of some unit cube? So for this problem, if we say like the total possibilities that we have, they are 6 to the power 4, right? And if we solve this, then we will get 1296. So these are the total possibilities that we have. But now in order to answer this question, we can solve it by using the case works. So let's make the first case. The first possibility is just assume that at the beginning the face is A plus, right? And then the B, it can go, if it is only moving in the planar, then it can go to B plus, B minus, C plus, C minus. However, it cannot go to A minus. The reason is if it go to A minus, then it will go back to A plus. So we have basically 4 options now. So once it goes to B plus, then the third move can be A minus, and then the fourth move could be B minus. So similarly, the path can be taken for the other options as well. For example, from A plus to B minus, then to A minus, and then to B plus. So if we see the total options then that we get from here, so they are basically 4. So we get then the 4 paths from this case. Now let's look at the second case, or case 2. So in case 2, we are considering now that all three axes they are involved. So if we consider all three axes, then we can see that again, let's say it starts at a plus, then the next step can be b plus, then a minus. Since all axes are involved, so the last option now it would be c plus or c minus. So if we have these cases and if I consider all of them, then the total paths or the total options that I will get, they will be then 4 multiplied by 1 multiplied by 2, right? Or I get then the 8 options. So another possibility that I can have there, that would then involve the perpendiculars which will not have a minus in there. So that will actually not having a minus in there. So let's call that case 3. So if we have third case, so I will then go from basically a plus to b plus to c plus to b minus, or I can go to c minus. And so now if we calculate the total options, so they are then 2 and then 2. So I get then 16 options. The total options that I have, they are 16 plus 8 plus 4. And if we add them, so then the total options that I get for the cases where the B can traverse along those 4 edges is equal to 28. However, this 28 is assuming that I start at A plus. However, I could have started any of that. So then I can multiply by 6. So now the total option that I get there, 168. And the probability is simply then the division of the successes divided by the total, that was 1296. And if I solve, then I would get 754. So the answer is then B for this problem. Here we are given that the figure below shows a dotted grid, 8 cells wide and 3 cells tall, consisting of 1 by 1 inch squares. So we are basically given 8 cells here and 3 cells here, and each of that is 1 by 1 inch square. Second, it says Carl places 1 inch toothpicks along some of the sides of the squares to create a closed loop that doesn't intersect itself. The numbers in the cell indicate the number of sides of that square that are to be covered by the toothpicks. And any number of toothpicks are allowed if no number is written. In how many ways can Carl place the toothpicks? So one of the restriction is that for the squares that have 1 written, only one toothpick can be placed for along its edges. So for example, we can have here, but then we cannot place at these locations. Similarly, if we are putting a toothpick here, then we cannot put another toothpick in these positions. So that is one restriction for the edges. And another is, if we note, if we are having along this edge, then we cannot have at the opposite edge. Or if we have along this edge, again, then we cannot have here. Or vice versa. If we have here, then we cannot have it here. So now we will solve this problem by creating different cases. Let's look at the first case. So the first case is very simple, where we can even create the loop without having any of the like without passing through the middle uh, or the second row. So this is our one case, right? And in the same way, we can have another case that is in this case, right? So we are having now two cases already identified. So now let's see what happens when we go through the center. So as I said earlier, like one of the possibility would be if we just simply put one here, and then we can have at the edges, right? Now we can create a path like this, and I can have something, let's say like this, and now I can have a path like this, right? So if you see, it meets all the requirements. It in all the cases it is only touching once along these edges, right? Or in the or here, and also the other one. So now the question is how many set paths we can have. So simply if you see, now we are having basically 1, 2, 3, 4, 5 and 6 positions left, right? So we basically then create 2 to the power 6 such paths. So let's say now what happens if I start, instead of starting at the extremes, if I start inside. So I can also start like this. And let's say that I go all the way. And now I can have a case like this, right? So there is no conflict. Um, and if we see now, I have 1, 2, 3, 4, 5. Okay, so these would be the ways we can rearrange them. And now if we can, instead of starting at this corner, I could have also started at this corner, right? So that would then give me another 2 to the 5 ways. So now let's see what happens if I also move, instead of starting at the last one, I move that inward. What it means is if I simply create a case, a path like this, okay, so let's see that what is another possibility. So that could be if I just go like this. So in this case, if I see now, yes, it also meets all the requirements, right? So it is touching one here, and yes, okay. So now if I see the options that I don't have, that would be then 2, 3, 4. So I will have then 2 to the 4 ways of rearranging it. So these are the possibilities that I have. So if you will try any other combination, then it will not work. So as I have already told you, based on those restrictions, so the total cases then you get, they are basically 2 plus 2 is 6 plus 5 plus 5 and plus 2 to the 4. So if we add them, then we'll get 146. So that is the answer for this problem.